All right, guys, let's jump right into going over this calculator section, and we'll hit the FRQs and then see what anybody else has got. So any questions on either one of these, 35 or 36?
Could you do 36, please?
Yes. All right. So we're given the function f of x, big F of x is the integral 0 to x to tan t dt. You have to be able to recognize that when I plug in x into that, I get f prime. So f prime of x is equal to 2 tan x. We want to find f double prime of 5. There's no need to have that memorized. I mean, obviously there's a need to have it memorized, but in this case, there's not. Okay, we don't need to by hand find the derivative of tangent and then plug in a 5 because we can just go right to our calculator. Okay, so at this point, I'm just going math and we're going back to option 8, which is derivative. So we're going to type into our calculator, move in a little bit on this. Okay, an x right here. And then our function is 2 tan x, and I'm in degrees right now, so I'm going to need to change that. And then we're going to evaluate that at 5. And before I hit enter, I'm going to need to change my mode there. And then it's just hit enter after that, and we get 24.856. So answer D.
Okay, if we were to like find the because the derivative of f prime is 2 secant squared.
Yes, that is correct.
How would we like put that in our calculator?
Okay, so if you're doing it that way, you would do this. Okay, secant is the partner of cosine. Okay, so you're going to do 2 times. This is a tough one. I guess I could just do that. 2 times 1 over cosine. There might be parentheses that needed to be here. Put the 5 in here, and then after you close the parenthesis on the 5, you square it. I think this might work. Yeah. Little,
Okay,
decimal wise, a little off, but that's how you would type it in. I probably, because that 2 times that thing in the front kind of scares me without parentheses, I probably would have done 1 over cosine to the cosine of 5 squared and then multiplied by 2, but it still works. But yeah, secant is 1 over cosine, and then probably the 2 biggest issues was that, and then the square goes here. We can't, in our calculator, we can't get the square to go right there. So we put it after this. If the square is inside these parentheses, then you're squaring your argument, which is totally different. All right, anybody for 35 before we flip over?
Can you do that one just in the calculator?
Yeah. All right, so we're doing f prime of 3. So f prime of x is 3e to the x over x. So I'm just doing the derivative of that in the calculator. So I'm not even going to type it in by hand. I'm just going to go math option 8. And there's an x there. And then my function is 3e to the x. You could hit the fraction bar, but you don't need to because it's not that tough of a function. 3e to the x over x. And then we type in the 3 right here. What did I do wrong? Oh, I did the derivative of that. That's dumb me. That's probably a big mistake. Is that one of the answer choices? It's not. Okay. That is f prime. I just did the derivative of f prime. I actually found the second derivative. We're just plugging in a 3 into this function. So we're literally just going 3e to the third. Oh, I got my divide in the wrong spot. Exit out of that. Divided by 3. And there you go right there. F prime of x is this. Careless error there, and I'm actually surprised that that's not one of the answer choices on the on there. All right, 30, let's just do 37 or 38 since that's all that fits on my screen right now.
Could you do 38, please?
Yes, 38 gives us a function, and it's the integral 0 to x t sine t dt is f of x concave up or concave down at x equals 4. So concavity is from the second derivative. My first derivative is just plug x's in, so x sine x. Okay. Again, I am not going to do this derivative by hand because that's a product rule with trig functions. It's just a pain. Okay. So at this point, I'm just going to do f double prime of 4. Okay. So that's in the calculator where we do the derivative of this at 4. So that's math option 8, d dx, and then x sine x at 4. And we get negative 3.371. So I would write down negative 3.371. And then I would say is less than 0. Therefore, it's concave down. All right, 37, anybody? All right, let's go to, let's just do 30, yeah, 39 or 40. I can fit those in there.
40, please.
All right, 40 says the functions f and g are defined on the closed interval 0 to b by f of x equals cosine 2x and g of x equals e to the x minus 1. They have the same average value if b is. Well, the formula for average value is 1 over b minus a is 0, integral a to b on cosine 2x. And we want to know when they're equal, have the same average value. So we're going to set that average value formula equal to the other one, 1 over b minus 0, integral 0 to b e to the x minus 1. Okay, we should recognize, excuse me, that these two are the same thing, so they cancel each other out. And now I'm just going to type that into my calculator. I'm going to do that in my y equals, okay? I'm going to find when this graph, this is a graph, is equal to this graph, okay? So the first one is math option 9. We're putting an integral in here. It's 0 to x. We don't have a b. 0 to x. And the first function is cosine 2x dx. And I'm graphing the second one in y2, which is the integral 0 to x e to the x, exit out of that exponent minus 1. And I don't know what a realistic window is. I have been messing with mine in my other classes. I'm just going to go negative 10 to 10, the normal window, and graph that and see where they intersect. Probably going to be a while. Matter of fact, I'm going to turn that off and restart this. Since that's going really slow, I'm going to go up my X res to say 3. So it'll graph a little faster. Still pretty slow. There we go. Picking up speed now. I probably have too big of a window here. But there's my first graph. And the e to the x graph. What did I do wrong on that one? Oh, I forgot to put my argument. All right, here we go. Oh, great. Anyway, you're going to graph these two, and then they're going to intersect. Obviously, I know the answer is 0.85. They're going to intersect right around here when x is 0.85. I hope when if I change my window, it's not going to take this long again. But here comes e to the x minus 1. And they intersect somewhere in here. Obviously, you want to find that intersection. It obviously is somewhere between 0 and 1. So I would just say at this point, second calc intersect, which is option 5. And then up here, I'm currently have my cursor on y1. So we'll call that the first curve. And then it jumped to y2. We'll call that the second curve. We're going to guess, but since the cursor is right around the area where we're at, we're good. If there were more than one intersection, then you would have to move your cursor or pick a number closer to the guess. And then we hit enter. And I don't know why it said 0, 0. Did I type it in right? I did. Let me zoom in on that a little bit. Let me change my window. -5 to 5, -2 to 2.
How do we cancel our, like, if it's like mine is still graphing, like,
Okay, so hit off your on off button and it will stop its graphing. And then go back into hit second quit once you do that.
okay.
And it should be fine there. Why is this saying it's at 0, 0? 0 to x cosine 2x e to the x minus 1. I'm not sure why this is not working because it did yesterday. Oh, it's not, it's on the it's up here. That's why it's this intersection. So it does intersect twice. It's that one that we're trying to find right there. Okay, not the one at 0, 0. Obviously the 0 is not one of the answers. So then we notice because of the multiple choice, it's not one. So we have to find that other one. So now we do second calc option 5, first curve, second curve, but on the guess, we do need to move the cursor to be a lot closer to that second intersection. And it's still thinking. It takes a while sometimes because these are so good and so slow. And then now you get the 0.854 right there. But the key there is understanding that they have the same average value when their graphs are equal. Okay. All right, let's go on. Did anybody have a question on 39?
Can you do that one, please?
Yes. All right. 39 says big f of x is equal to the integral of 0 to x function dt. Is f of x increasing or decreasing at x equals 3? F of x is increasing when f prime. Okay, I'm going to write this down. You wouldn't write this on your test, but increasing when f prime is greater than 0, decreasing when f prime is less than 0. So I'm going to find f prime of 3. F prime of x is 2 sine x over x plus 1. F prime of 3 is, plug a 3 in, 2 sine 3 over 3 plus 1. So I'm just going to go to my home screen on that and just do 2 sine 3 divided by, I'll do that in my head because I don't want to have to put parentheses, 4. And I end up with 0.071, which is greater than 0, therefore increasing. I don't know if you can see that. I'm sorry, I was moving it all over. All right, let me flip to the next page, the last two. All right, let's do 41 first. Got velocity function. Asked to find total distance and displacement. That's just integrating. I wrote the formula out there, so that shouldn't be a problem. Everybody good there?
Can you show how you could do the absolute value thing in the calculator?
In the calculator? Yeah. So you're gonna hit math option 9. You're gonna put your integrals, your limits in. I'm just gonna make them up for now, right? And then when you arrow over to this, before you start typing anything in, hit math and arrow over to number, and it's the first option, ABS. And then your absolute value bars will pop up. And then you type in your function and then put your X out here, okay? All right, let's go to 42. A and B, same thing as A and B on the top, right? Displacement, no absolute value bars, total distance, absolute value bars. Any questions on C or D?
Could you do C, please?
Yes, when is the particle slowing down? That is when acceleration and velocity have the same, have opposite signs. So you're going to say when V of t and A of t have opposite signs. And then it's just a matter of looking at the graph. Okay, so we're going to go graph the velocity function, which was 8t squared minus 16t or x. Okay, I'm just looking at that function. So, and I only want to look at that from 0 to 4. So I'm going to change this to be from 0 to 4. Probably change my y's to go a little bigger, but I don't know if that matters. All right, so there's that function right there. Okay, we probably need to find that point, but it looks like it's at 1. Okay, that minimum point there, but you might need to find that just to make sure it's at 1. But what we need to realize is that from 0 to what appears to be 3, velocity is negative because we're below the x-axis, and from 3 to 4, velocity is positive. Okay, we want opposite signs. Right here, velocity is negative until we get to this minimum right here. And acceleration is also negative because the slopes of all these tangent lines would be negative. And once I go from here to here, my velocity is still negative, but all the slopes here are positive. So this is 1 to 2, where opposite signs. And then when I get above the x-axis, my velocity is positive and my acceleration is still positive because we still have positive slope tangent lines. So there we're the same sign. So the only time we're opposite signs is from 1 to 2. And then I would say, like I think I wrote on the paper, from the interval, on the interval 1 to 2, velocity is negative and acceleration is positive. All right, anybody for D? All right, if you have questions on the FRQ, let's hit those up now. So I posted the answers. We'll start with the non-calculator question, but if you need me to explain something on that one, just let me know. All right, how about on question 2? All right, guys, tomorrow we'll do the non-calculator part of the test. And then on Tuesday, we'll do the calculator. If you need to contact me, especially over the weekend, and ask me a question, I do check my Canvas occasionally. And I'll be working Monday. It's a work day for us, just not a school day. So I'll be able to answer your questions then. Have a great day, and I will see you next week sometime. But don't forget to be there for your test tomorrow and get it into me by 9:30.
Mr.